Today we begin our study of geometry with Unit 1.1, Lesson 1 on points, lines, and planes. The three main building blocks of geometry are points, lines, and planes. And even though we understand the idea of each of these things, we know what a point is, we understand what lines are, what they look like, they have no formal definition in geometry, and they are referred to as the undefined terms. A point has no size and is represented by a dot and named with a capital letter. Just like that, point A, always a capital letter. A line extends infinitely in two directions, so think of a number line. It has no thickness. There are a number of different ways in which we can name a line. One way is to use a lowercase cursive letter, like line L, just like that. Or we can use points that are on our line. So maybe we have point A here, point B here. So we can also refer to this line as line AB. Notice the capital letters. And then to tell the reader that it's a line, we put a little miniature line above it. So we use a little symbol for line. Now, when you name a line, you only need 2 points, but it doesn't matter the order in which you name those 2 points. So we can also refer to this line as line BA. A plane also extends infinitely. Usually we use like a parallelogram to represent a plane. It has no thickness. Sometimes we use a sheet of paper to represent a plane, but that's just to represent the plane. The plane itself would not have even the thickness of a sheet of paper. Now a plane is labeled with a capital letter. It's a cursive letter, and so we can refer to this as plane M. So we think about a plane as being a flat surface that extends, in its length and its width. We might also see planes in three-dimensional objects. For example, if you think about a prism, like a shoebox. And if we name the points at the corners, the intersections here, point A, point B, point C, and point D, and if I highlight the top of this box, each of the sides of this prism is a plane. So we can also name the top of this box plane A, B, C, D. So when you name a plane, it either has to be an uppercase cursive letter in the corner of your plane, or you need to use 3 or even 4 non-collinear points to name that plane. We'll talk about non-collinear in a minute. Space is the set of all points. Collinear points are points all in one line. So first we'll draw an example of collinear points. So draw a nice straight line, and let's put points A, B, and C on there. So points A, B, and C are referred to as being collinear because there's one line that contains them all. For an example of non-collinear points, all we need to do is show that some points are on the same line. Like A and B are collinear, but point C and point D are not on that line. There isn't one line that contains all 4 of those points, so they are considered non-collinear points. Coplanar points are points all in one plane. When we show coplanar points, again, we usually draw a plane and just show that these points are within that region. Okay? So these are coplanar points. Showing that points are non-coplanar is a little bit trickier because now we have to draw a three-dimensional object. So if you draw one plane, and now we're going to draw a second plane intersecting with this first one. It's a little tricky to make it look three-dimensional. Just do your best anytime you have to draw a figure. So we do a dotted line to show that that's where the second plane would be intersecting the first plane. And when two planes meet, they form a line. So again, we're trying to illustrate non-coplanar points. So that means we would have some points in this plane and some points in this plane. But all of those points are not contained within one plane, so they are considered non-coplanar. The intersection of two figures is the set of points that are in both figures. For example, the intersection of a point and a line is simply that one point that is on the line. So we can say that point A is in line L. We can say that A is on L. Either is appropriate. We can also phrase this a different way and say that line L contains A. Or we can say that L passes through A. So lots of different ways to say the same information. The intersection of two lines is a single point. For example, if we have line H and line L, you can see that because they are straight lines, they meet at a single point, which we're going to call point O. So we can say that H, script letter H, and L intersect at O. You can also say they intersect in O. And another way to phrase this would be to say that O is the intersection of the two lines. So O is the intersection of line H and line L. When we talk about the intersection of a line and a plane, there are two different scenarios that can occur. The first is that the line, the whole entire line, which we'll name K, could be contained in the plane. So every point on line K is in plane M. So K is in M. The other situation that could happen is that instead of the whole line being in the plane, the line could come down and intersect the plane in one single point. So this is showing you a line, we'll call it L, that comes down and intersects or touches the plane at this point and then goes through the plane and comes out the other side. That point of intersection we'll call point P. So point P is in plane M, and we can say that P is the intersection of L and M. When we have the intersection of two planes, it is always a line. Now, because this is a three-dimensional picture, it's a little bit tricky to draw. So here's our first plane. I'll call it M. Our second plane is going to intersect with this first plane. So again, I'll do a dotted line here to show that's the part we wouldn't see because of the intersection. But where these two planes meet, and again I will demonstrate this for you in class, they meet at this line right here. Now I know it looks like it stops, but remember that planes are infinite and they go on forever. So this line where they intersect would also go on forever. So I'm going to name a point X and a point Y on that line. So we can say that M and N intersect in line XY. You could also reverse it and say that line xy is the intersection of M and N. You could say that line xy is in M and N. And you could also say that the planes M and N contain the line xy. Okay, now it's your turn. Take a few minutes to complete the practice questions. Using the figure, answer the true-false questions, and then the fill-in-the-blank questions for numbers 11 through 14.